Sorry, everybody, keeping you online because we're just having a small break here in the room. But we're getting back to our seats now, and we're going to start again. And I'm very, very happy to now introduce you to another well-known figure on this scene, James Carpenter, who coordinates science for ESA's exploration activities at Moon and Mars in the Directorate of Human and Robotic Exploration. James, can you hear me? I can see you, James. Can't quite hear you yet. Haven't quite got...
Am I on?
Yes, now you're on. I can hear you, James. Over to you.
Super. Thank you. Great. Thank you very much, Lisa. So hello, wherever you are, and thank you for joining us this morning or this afternoon, depending where you are, for this session on new discoveries. So over the next couple of hours, we are going to explore some extraordinary new discoveries and some new developments that are ongoing from asteroids to Mars to the Moon. We have 8 speakers. Each speaker is going to have 15 minutes to present, and I'll give them a heads up at around 10 minutes if the technology allows, to let them know their time is coming to an end. And at 15 minutes, I'll ask them to bring things to a close so we can move to the next speaker. If we have time, then hopefully we'll have time for questions for the speakers, and I'll take questions from the chat in order to represent you and ask your questions for you to our speakers. So with that, I would like to move straight away to our first speaker, Makoto Yoshikawa from the Japan Aerospace Exploration Agency, JAXA, who's going to tell us all about Hayabusa, some of the operational challenges and results on asteroid Ryugu and its properties. So please, I hand it over to you, Makoto-san.
Yes. Can you hear me? Okay. Okay. I am very happy to talk about the Hayabusa 2 today. So can you see my slide? Yes, thank you. So I don't know, I can change the slide. No. Okay, so next page, please. Yes. So this slide summarizes the Hayabusa 2 mission. Hayabusa 2 is the second asteroid sample return mission in the world following Hayabusa. And the target asteroid is Ryugu, which is C-type near-Earth asteroid. And the science objective is to study origin and evolution of the solar system and the life. And the organic matter at the beginning of the solar system is very important. And engineering objective is to develop technology that perform round-trip mission reliably. As you may know, in the original Hayabusa, it had several serious problems. So we modified the spacecraft, and the Hayabusa 2 did not have a big problem for a 6-year trip. Next slide, please. Yes, so this is a Hayabusa 2 spacecraft. It is not so big. The body size is about 1 meter by 1.6 meter by 1.25 meters. And the total mass, including fuel, is about 600 kilograms. But it has many payloads. In the lower left, you can see 4 science instruments. And the lower right, you see small lander and rovers. A small lander, that is mascot, which was made by DLR and CNES. And there are 3 small rovers, which is called Minerva 2. And Hayabusa 2 has an impactor, and we did the experiment of impact experiment, and we created an artificial crater on the surface of Ryugu. Okay, next page, please. This shows the mission sequence. Hayabusa 2 was launched December 2014, and just 1 year later, it came back to the Earth to perform Earthing by. And then 2.5 years later, it arrived at its destination, Ryugu. And we observed Ryugu, and in September 2018, we released two small rovers, Minerva 2-1. And then we released mascot, Nanda. And the first touchdown was executed in February 2019. And then we did the impact experiment. And in July 2019, we did second touchdown. We got the subsurface material near the impact artificial crater. And then we made a artificial satellite experiment. We released two target markers and one small rover Minerva 2 into the orbit around Ryugu. And finally, in November 2019, Hypsa 2 left Ryugu, and it came back to the Earth in December last year. Okay, next slide, please. Yes, these are very nice images of Ryugu. And sorry, just please go back to the previous page. Yes, so these are very nice images of Ryugu, and you can see maybe the movie is not working, but it's a pity. But you can see the surface of Ryugu in upper figures, and actually in lower figure, I put the movie of touchdown. And you can see the impact crater in the middle figure. Okay, next slide, please. And this shows the return trajectory. It took just 1 year to come back to the Earth. And the right figure shows the re-entry flight sequence and the capsule search. The re-entry capsule deployed parachute at the altitude of 10 kilometers. And then a beacon signal emitted, and we were able to find the capsule quickly. Okay, so next page, please. Yes, this is a very nice photo that shows the fireball by capsule. Maybe the movie doesn't work. Okay, the right figure is very beautiful photo. The fireball of capsule. Okay, this is December 6th in last year. Next slide, please. And this shows the re-entry capsule. In the left figure, you can see green part. The green part is sample container, and you can see the structure inside of sample container. The inside of sample container, there is a sample catcher. And the sample catcher has 3 chambers, chamber A, B, C. And in chamber A, there were the samples of first touchdown. And in chamber C, there were samples in second touchdown. Now I show you the samples of Ryugu. So next slide, please. Yes. So this is a photo of inside of the chamber A. So this is the sample of first touchdown. You can see lots of dark material. And the total mass, including the second touchdown, is about 5.4 grams. So our target mass was just 0.1 gram. So we were able to get much more samples. And next slide, please. Yes. And just please click the. Yes. So this is inside of the sample container. In sample container, there are a little amount of Ryugu sample. I think you can see dark grains in it. And click again, please. Yes. So this is a sample of the first touchdown that you saw just previous slide. And click again, please. Yes, this is samples of a second touchdown. You can see the sample is much larger in second touchdown. The largest sample is about 1 centimeter. Okay, so next, please. Yes. Again, this is an image of samples. Upper figures chamber A, so first touchdown, and the lower figures chamber C for the second touchdown. Here, we picked up large particles, so you cannot see large particles here. And now we are starting to analyze these samples. So I am very looking for the result.
I've been asked to just warn you by James, who's a fantastic chairperson, that you've got a couple of minutes left.
Okay.
Thank you.
Yes. So this slide shows the sample distribution schedule. So from this June, we will start the initial analysis. So I think in this year or next year, we will find the nature of this sample. Okay, so next slide, please. So this shows the extended mission. Since spacecraft is healthy and it has 50% of fuel of ion engine, we decided to do the extended mission. And the target of extended mission is 1998 KY26. So next slide, please. Yes, this shows the target asteroid. It is very small, just 30 meters in diameter. And but there's one problem. It takes a long time to arrive this asteroid. We need still 10 years. Okay, so next slide, please. So this summarizes what we have known about the Ryugu. So Ryugu is a lab-pile structure, and the spin period may be much faster in the past. Maybe spin period is about 3.5 hours in the past. And Ryugu has hydrolyzed mineral, carbon-rich, and small surface strength. And now we estimated its orbital evolution. We think Ryugu once approached to the sun very closely. Okay, so next slide. This is the last slide. Yes, this is just summary. So the HyPSO 2 mission was quite successful. So now next thing is sample analysis. So we are looking for the result of sample analysis. Okay, thank you very much for your kind attention.
Great. So thank you very much for the speech. So sorry, the technology is a little bit awkward for chairing the session, but we're going to sort it out. I had maybe just a question for you. What key lessons can you take from this that future asteroid miners really need to know?
Yes. Please say it again.
Sorry. So my question was, what lessons would you take from this experience that you would want to pass on to prospective asteroid miners? So somebody who really wanted to go and mine them, like what experience can you take away from this that they really ought to understand?
Yes. The most important lessons learned was the surface of asteroid. So the surface of asteroid was very rough. So we must think much better way to get the sample, even if the surface is not smooth.
That's great. Now, and there's one question I see on the chat, and I'm sorry if I've missed something here, but there was a question about what was the purpose of chamber B?
Chamber B, actually, HIABSA 2 can touch down 3 times, but we did only twice. So chamber B is nothing.
That's great. Super. Well, thank you very much indeed. Much appreciated. Thanks for your talk.